So in this section, we are going to look at electric circuits. And an electric circuit is a closed path along which electrons can flow, we call that current, from and return to an energy source. So electrons can flow from and return to an energy source. And current is the number of charges that move past a point in a given amount of time. So we can have alternating current, which is current that flows back and forth, used to power our homes, and direct current, in which electrons flow in one direction from the negative to the positive terminal. So this type of current is found in cells, for example, batteries. So the two locations in a cell that has to be connected to the other components are the positive and negative terminal. Without that connection, this circuit will not be complete. A terminal is a location on a cell that must be connected to the other components to form a circuit. The load is a resistor or any other type of device that transforms electrical energy into heat, motion, light, or sound. A couple of other terms that we need to know about circuits is that we can have an open circuit, and this is a circuit through which current cannot flow because it contains a gap or switch, a break, or because the switch is open. And a closed circuit is a circuit through which current can flow in an uninterrupted path. So here is a picture down of what the components of a circuit can look like. Some components. We have a switch, a light, and a battery. Now, if we were to draw out the circuit symbols for this, we would show this would be our, could be our battery. If this was 1.5 volts, then this would only be a short line and a long line. Actually, this is the negative terminal. Yep, so that's short. And then this would be like this. So ignore this little lines here. I'll have to delete that. But this switch here is closed. And this is the closed switch right here. This is an open switch. So in this case, the light bulb is not lit up. But in this case, the light bulb is lit up. We will spend some more time doing circuit diagrams in the next section. Just going to grab my whiteout and fix that diagram. So let's just make that a bit more the way I want it to be. So the short line is the negative terminal, and the long line is a positive. So if we're copying this here, I'm just going to keep the same form. It would be like that. So we need a long line and a short line. Negative, positive. So in this case, the electrons are flowing. And this is why the light bulb was lit up. And the electrons will flow from the negative terminal all the way back to the positive terminal. So here, no electrons are flowing. Okay? So how do electrons move? If a conductor such as a metal wire is not part of an electric circuit, the electrons will move in random directions. And we'll see a picture of that in a minute. So the electrons do not flow in one direction along the wire. But once a current occurs, because of a chemical reaction that occurs inside a cell, the charges will separate, and an excess of electrons builds up at the negative electrode, and there's a deficit, meaning there's no electrons or not enough electrons at the positive electrode. So as a result, the electrons will move in one direction through the wire. So how does that look like? This is the diagram here. So here we see that the electrons are moving randomly because there's no current. But here, once the current is out, this is a battery. The electrons are moving in this direction, negative to positive. And you see that all the ions are moving in one direction. So electrons move through a wire as marbles would move through a tube. So you could see that this is what's happening right here. Okay, so that is how electricity moves. So now we've seen in this lesson how current flows and some of the components of a current. In the next lesson, we will look more about how to draw a circuit diagram, or what the components of a circuit are.